Welcome back to Chemistry from Jay's house. So today we are going to be answering the question about diffusion. So let's write down, let's see, I think this is the 26th, I think is when you're supposed to do this. That might not be the right date. It's also non-focused. There we go. If that's not the right date, put the right date. Skip line, go all the way left, right, the point. And the point is, do all gases diffuse at the same rate? Now, if we were at school, we'd actually do a lab around this. And we would choose a couple of gases and we would see, do they diffuse at the same rate? But what does diffusion mean? That's a really good question. Let's figure that out. So if you're taking paper notes, remember, skip a couple lines so you can put the answer down. Diffusion is the movement of a fluid from an area of higher concentration to an area of lower concentration. That's the only note for today, so pause the video, write that down, and then we'll come back. Pause. Welcome back. Okay, so what does this mean? First thing is, what's a fluid? We need to figure out what a fluid is. A fluid is anything that can change shape, anything that flows. So liquids or fluids, gases or fluids. We're going to talk mainly about the gas portion of diffusion, but it also works for liquids. So we're going to start with liquids. So let's say that I have a cup here, and it's full of that magical substance called water, right? And what this means is if I put some lemonade powder in the bottom. Now, we know from our solutions unit that this would become a solution, but first we'd have to agitate it. But there's actually microcurrents in here, and if I wait long enough, and that's a really long time, so that's like I pour it in there, and then I wait a couple days, what would happen? Well, what we would see is right here, right now, has a very high concentration. There is a lot of lemonade powder down here, and this area up here clearly has low concentration. There's not much lemonade powder at the top at all, right? And what diffusion says is that given enough time, everything moves from a higher concentration to a lower concentration. So that means I wait long enough and that dot is going to get brought up there, and that dot will get brought there, and those dots will get brought there, and those dots will get carried over to there because they are fluids and they can move around. And these dots will get dispersed here, and those dots will get dispersed there, and that dot will end up over there. And when we wait long enough, what ends up happening is it diffuses. And what that means is we now no longer have low concentration. We now no longer have high concentration. We have diffused to equal concentration. Throughout. or we've made a solution, right? So diffusion is simply that if you have high concentration, a lot of stuff, what will end up happening is it will flow through the fluid and fill the void, because there was a relative void here. At the top, there wasn't much lemonade powder. Now, there is. So fluids diffuse from high concentration to low concentration until they hit a thing called homeostasis, until it is equal concentration throughout. So now if I take a sample here, if I take a sample there, take a sample there, they would all be equally lemonade-y, right? And that's diffusion. And you've seen that. I mean, you've made lemonade sometime, or chocolate milk, or hot cocoa, or whatever other stuff. You've reconstituted dehydrated milk. No, I haven't. Yeah, I know people don't really do that anymore. Okay, but what does this mean for gases? So if we imagine a room, and there's a door in the room, right? So there's the room. And it is a room where I am over here. Hello, that's me. And I am smelling wonderful. And the air around me smells wonderful. And I am quite content with how this room and myself are feeling. And then you, being a teenager, and you come in and you have recently coated yourself in Axe body spray, which means right around you there is a cloud, a very dense high concentration of Axe body spray particles. Now note, we have over here high concentration of terrible smell.
What do you mean? Yo, my Axe body spray is totally dope. It totally helps me get the people be attracted to me at the mall.
Yeah, sure does. You keep trying. Right? And over here, we have low concentration of wonderful, not Axe body spray smelling air.
Yo, you're totally never gonna get somebody attracted to you at the mall smelling like that.
Well, I hope I don't try to pick people up at the mall because I'm old. Okay. And what's going to happen? Do you think that my air will continue to smell fine, uncontaminated, not like the Orange Julius at the mall? Or do you think some of these particles are going to diffuse? And tragically, the answer is this particle here will go there. And this particle here will flow there. And these particles here will flow there, and there. And these particles here will flow there. Because gas is also a fluid. So these particles end up over there, and these particles end up here, and these particles there end up there. Because there's all these kind of micro air currents in the air we breathe. Every exhale adds another kind of microcurrent, and then you have like air conditioning, and when you open the door, there's another air current. When you close the door, there's another air current, right? So all these things are pushing air around. Air is also a gas, so it's forming its own air currents just by the particles racing around. And then tragically, I get to smell your Axe body spray. Yay! So, not that I've ever experienced this in the classroom, not that anyone has come in smelling awesome, and I've got to smell awesome all class period long. No, this has never happened. Only every day. So, and it's because it's a fluid. because the particles can move all around, what ends up happening is areas of high concentration, as they bop around, they get basically launched out into areas of low concentration. And they're going to keep bopping around randomly until everything is equal concentration. So now you'll notice that we no longer have low concentration. We no longer have high concentration. We now, throughout the entire thing, we have equal concentration. More or less.
Yeah, but if I were to take a picture, I'm sure there'd be actually some kind of clumping, like maybe this little area might have a slightly higher density of Axe body spray particles than, let's say, this area.
Yes, that's 100% true. It's not going to be exactly mathematically equal, but on average, we'll have equal concentration throughout the entire room. And that's because it's a fluid. And the main thing is, this happens because no one is driving. No one is making sure that these go anywhere. If we could like use magnets or some other force, then we could, suck them all back to this person, have this person live in their terrible pig pen cloud of Axe body spray. But no one is controlling it. So they just spread out. It's the randomness that makes this happen. It's not that the universe is reaching in and being like, excuse me, if you could go right there. Perfect. There you go. And, let's move you over to there. Oh, this is going to work out wonderfully. No, the universe is not doing that. The universe just is letting these things bop all around. And since no one is driving, they end up going everywhere. Just simple as that. That's called diffusion. So now that we know what diffusion is and we know why gases diffuse because it's random. Gases diffuse because no one's telling them what to do, so they do whatever in heck they want. I like to think of it as if you give my younger daughter paint and you leave the room for a while, you cannot predict where the paint will be, but there will be paint somewhere in that room. No one's telling her what to do, so she'll get paint on the wall or on the floor or on the door or on me, right? And gases are the same way. No one's driving, no one's coordinating it, so who knows where they're going to go? Because no one's driving, well, they go everywhere. So gases diffuse because they are a fluid, and because no one's driving, they end up just bopping everywhere, which means higher concentration becomes lower concentration just because they equal out through their random movements. Now, do they all diffuse at the same rate? So this person came in wearing terrible Axe body spray.
Well, the Axe body spray I wear is not terrible.
Nope, it's all terrible. There you go. So what if this person came in wearing terrible, expensive perfume? That has also happened in my class and on airplane rides and other places. Would the terrible perfume reach me just as fast as the Axe body spray reach me, right? And that's the question is, how fast do these things move throughout space? And is it standard? Does it matter what this person is wearing and how long it takes me to smell their terrible decision earlier today, right? I don't know. Let's find out. So first, let's get rid of all this.